Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is set 2 of 5 good problems on the topic of area of polygons, where I will solve the next set of relatively harder 5 problems. If you have not watched the set 1 of solving 5 good problems on this topic of area of polygons, by polygons I mean that includes triangles, quadrilaterals, parallelograms, trapeziums, and regular and irregular polygons. I strongly suggest and request that you also watch the set 1 video. So this video is part of the playlist Maths 8 Hot. HOT Hot stands for High Order Thinking, where I come up with 5 relatively harder problems and solve them from chapter as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the set 2 of 5 good problems on the topic of area of polygons. Okay, so I hope you can read the problems on the left hand side. The fonts are big enough so that you can see it properly. On the right hand side, I will solve the problem. As usual, always try to solve the problems yourself first. Ideally, you should be able to solve these 5 problems in 30 minutes, taking 6 minutes per problem. If you are stuck or if you want to see my way of solving the problem, please see this solution video. And while solving this problems, always take notes of any new ideas or concepts that you see or you will come across. Okay, so let's start solving the problems. Question number 1 says there is a figure in the rectangle ABCD. E and F are points on AD and BC respectively, such that AE is to ED is 1 is to P and BF is to FC is P is to 1. If AB is equal to X and BC is equal to Y, then area of the quadrilateral EDBF, EDFB, the area of the quadrilateral EDFB is, okay. So since okay, so ABCD is a rectangle. At the point E is dividing the side AC, the side AD in the ratio 1 is to P. And also, okay, so what we can see, it is given that AE by ED, AE by ED is equal to 1 by P. Okay. 1 by P. Now, okay, first of all, how can we find the area of the quadrilateral EDBF? Quite possibly, since from the ratio, given ratio, you will see that AE will be equal to FC. If AE is equal to FC, then definitely ED will be equal to BF. And ED and BF are already parallel, are already parallel. So, and they are equal. So EDBF, EDFB will be a parallelogram. Okay, so we have AE equals to AE by ED equals to 1 by P, and we have BF by FC is equal to 1 by P. Now this implies, what is AE? What is AE? Now AE, from the concept of ratio and proportion, please note that AE will be since AE plus ED is equal to AD, since AE plus ED is equal to AD, which is equal to given as BC is given as Y. So this is Y, and that AE is to FD is equal to 1 by P this will imply that AE will be equal to, from the concept of ratio and proportion, 1 by 1 plus P whole multiplied by Y. Similarly, since FC plus BF is equal to BC, and it is given that BF is to FC, BF is to FC is P is to 1, P is to 1, this will imply that FC will be equal to 1 by 1 plus P multiplied by BC, BC is Y, so multiplied by Y. So you can see that FC is equal to AE, both AE and FC is equal to Y upon 1 plus P. Okay. Now my idea is that I can easily find the area of the rectangle ABCD since its length and breadth are given, that is x and y, and from that area I will subtract the area of the two right angle triangles AEB and FDC. Okay, so let me quickly draw the figure and explain what I am going to do. So ABCD is the rectangle, ABCD is a rectangle. So clearly we have, this is right angle triangle. So here we have E and here we have F. So clearly AEB is a right angle triangle, and also FDC is a right angle triangle. Okay. Now and also you will see that ED BFB will be a parallelogram, Now you can find the area of this parallelogram somehow and subtract the area of the parallelogram from the whole rectangle. That, oh, what is the then area of the quadrilateral EDFB? Okay, so we are asked to find the area of the quadrilateral EDFB, which will be actually a parallelogram. At the moment I am not familiar what is the formula for finding the area of our parallelogram. So I will solve this way. I will find the area of the triangle AEB and DFC. Now please note that, so we got AE is equal to FC, which is equal to Y upon 1 plus P, and also we have AB is equal to DC, since ABCD is a rectangle and AB or DC are opposite sides. And also we can see that angle BAE is equal to angle DCF, which is equal to 90 degree. So this clearly implies that triangle BAE will be congruent to triangle DCF. While mentioning, giving the name of while writing the relation, congruence relation, you should be very careful in writing the name of the triangles properly, because in a congruent relation, the way you write the triangles, that eventually says what is the correspondence between the vertices of the two triangles. Okay, so we have this. Now this implies if two triangles are congruent, I can clearly say that area of triangle BAE should be equal to the area of triangle DCF. Area of two congruent triangles are always equal. Okay. Now what is area of triangle BAE? Area of triangle BAE, applying the formula of half into base into height, the base we can consider as AE and height is AB. Since AB is perpendicular to AE, this is equal to, what is AE? AE is half multiplied by AE is Y upon 1 plus P. And what is AB? AB is given as X. So this is equal to XY divided by 2 multiplied by 1 plus P. Okay. So this will imply that the area of quadrilateral, which is basically a parallelogram, EDFB will be equal to area of rectangle ABCD minus twice of area of triangle BAE. This is equal to, what is area of the rectangle ABCD? That is x into y, length into breadth, minus what is twice of area of BAE, which will be 2 multiplied by the area of triangle BAE is xy divided by 2 upon divided by 2 multiplied by 1 plus p. This is equal to xy minus xy by 1 plus p. This is equal to, if I take out xy as common, I have xy 1 minus 1 plus 1 minus 1 by 1 plus p. After simplification, this will be this will be xy multiplied by p by 1 plus p. Okay, so this is p into xy divided by 1 plus p. So this is the area of the quadrilateral EDFB. So the correct choice is C. Sorry, C. C is the correct choice. Okay, let's do problem number 2. Problem number 2, there is a figure. Okay, so there are two circles. Okay, AB and CD are the diameters of two circles. AB and CD are the AB and CD are the diameters of two circles with radius R1 and R2 and touching at the point E. So the two circles are so the circle with the diameter AB, its radius is R1, the circle with diameter CD, its radius is R2, and the two circles are touching at the point E. The points X and Y are centers of the circles, and XEY is a line segment which is perpendicular to AB and CD. Okay. If area of the quadrilateral ABCD is 25 square units and R1 multiplied by R2 is 4, then the ratio R1 is to R2, where given R1 greater than R2 is, then the ratio R1 is to R1. Actually, in the figure, the figure shows that R1 is less than R2, but in the problem it is given R1 greater than R2. Anyway, okay, area of the quadrilateral ABCD is given. Okay, so let's quickly draw the figure. We have a small circle, we have a bigger circle. Let me touch the two circles. Okay, so X is the center of the smaller circle, let's say Y is the center of the bigger circle. So AB is the diameter of the first circle, that means that AB will pass through X, the center, AB. And also CD is the diameter, so it will pass through the center Y. We have the quadrilateral ABCD. And it is saying that the point of intersection, the two circles touches at the point E. Let's say this is E, and XEY is the line segment, and it is also perpendicular to both AB and DC. Okay, fine. Okay, so what do we have? We have AX AX should be R1, since AX is the radius of the smaller circle, and also we have dy dy is equal to R2. Okay. Also AB is the diameter of the first circle, so it should be twice of R1, and CD is the diameter of the second circle, it should be twice of R2. Okay. Okay, so XEY is perpendicular to AB, and XEY is perpendicular to CD. These two implies that AB is parallel to CD. AB is parallel to CD. So we have AB parallel to CD. Now we can think of ABCD as a, so this will imply that ABCD is a trapezium. ABCD is a trapezium where we can see AB is parallel to CD. These are the two parallel sides, and height will be equal to the height of this trapezium ABCD, denoted by the small h, will be equal to XEY, the length of the segment XEY, which is equal to XE plus EY. Now what is XE? XE is nothing but the radius of the smaller circle R1, and EY is nothing but the radius of the bigger circle R2. Okay, so the height of the trapezium is R1 plus R2. The height of the, so ABCD is found to be a trapezium where AB is parallel to CD, and XEY is the height. So the so where AB is equal to twice R1, DC is equal to twice R2. So we have the length of the two parallel sides of the trapezium ABCD, and the height is R1 plus R2. Okay. Okay. So what is the area of trapezium ABCD? Area of trapezium ABCD is, we know, half into the sum of parallel sides, which will be AB plus DC, and the height. This is half into what is AB. AB is twice R1, and what is DC? Twice R2, and what is height? Height is R1 plus R2. If we take out 2 common from twice R1 plus twice R2, we have R1 plus R2 multiplied by R1 plus R2 divided by 2. So this is, after simplification, R1 plus R2 whole square. R1 plus R2 whole square. This is given to be, the area of the quadrilateral ABCD is given to be 25 square units. 25. So this implies that R1 plus R2, that is the sum of the radius of the two circles, is square root of 25, which is equal to 5. I am ignoring the units. I hope you will understand. Okay, so the actually no unit is given. It is given as square units. So R1 plus R2, you can write it as 5 units. Anyway, so R1 plus R2 is 5. Okay. It is asking the ratio of R1 is to R2. R1 into R2 is given 4. Now, if you know R1 plus R2, and if you know R1, R2, then from algebraic expressions and identities, I hope you will understand that I can find what will be R1, what will be R1 minus R2, that is R1 minus R2 square, I know, will be equal to R1 plus R2 square minus 4 R1 R2. This is an algebraic identity that A minus B whole square is equal to A plus B whole square minus 4AB. Now what is R1 plus R2 here? This is 5. So 5 square minus what is R1 R2 is given as 4. So this is equal to 25 minus 16, which is equal to 9. So this implies R1 minus R2 is equal to square root of 9, which is 3. So we have R1 plus R2 is equal to 5, and we have R1 minus R2 is equal to 3. If you add them up, add this to equation, we get twice R1 is equal to 8. This implies R1 is equal to 4. If R1 is equal to 4, this implies what will be R2? R2 will be 5 minus 4, which is 1. So this implies it is asking R1 is to R2. So R1 by R2 we get is what is R1 4 and what is R2 1. So this implies that R1 is to R2 is equal to 4 is to 1. Even though the answer is looking weird, this means that the radius R1 is greater than R2, but in the diagram, the way the diagram has been drawn, it clearly shows that R1 is greater than R2. Sorry, R1 is less than R2. Anyway, so in the given problem, it must have been given that R2 is greater than R1. In that case, I would have found, instead of R1 minus R2 square, I would have found R2 minus R1 whole square. Anyway, so this is the result. R1 is to R2 is 4 is to 1. So the correct choice is D. D is the correct choice. Okay, let's do problem number 3. Problem number 3. There is a figure given in the regular nonagon A B C D E F G H I. So we see a regular nonagon. Nonagons means nonagon means 9-sided. Nona means 9-sided regular. Nonagon means 9-sided polygon, not regular but 9-sided polygon. A polygon having 9 sides. So the given figure is a regular nonagon. So it's a regular 9-sided polygon A B C D E F G H I having side length of A. So A is the length of each side. O is the center of the polygon or regular nonagon that makes congruent isosceles triangles with each side. Okay, so the center is making, if we the center is creating isosceles triangles with each side, and each of these isosceles triangles are congruent. If the perimeter of each triangle is 5A, then the area of the nonagon is okay. So I will just please note that so this is the, let's say, consider a single isosceles triangle. This is the center O, and this is an isosceles triangle. This is an isosceles triangle. Let's say this is OHG. So this is A. This is A. Each side of the AG is a side of the regular polygon, regular nonagon, and each side length is given as A. So AG is A. And the perimeter of this triangle is given as perimeter will be OH plus HG plus OG is given as 5A. Now we know that also a triangle OHG is isosceles triangle. So OH is equal to OG. So we have OG OH plus HG plus OH is equal to 5A. This implies twice of OH is equal to 5A minus HG. What is HG? HG is A. This is 4A. So this implies OH, that is the side, the equal side of the isosceles triangle is 4A by 2, which is twice A. Okay, so this is twice A and this is twice A. We have to find the area of this entire regular nonagon. Now, one concept I have already discussed in the theoretical video where I was discussing about how to find the area of regular polygons. I said that there are two methods of finding the area of regular polygons. One is by dividing the polygon into some rectangles, trapeziums and triangles, and the another was based on some formula, and the formula was area of some regular polygon, area of a regular polygon is equal to n a h by 2, where n is the number of sides, of the polygon, regular polygon, a is the length of each side of the polygon, length of each side of the polygon, and h is the length of perpendicular from center, that is center of the regular polygon, which in this problem, in this figure is O, length of perpendicular from center to any side, So now if I draw in this triangle, isosceles triangle OHG, if I draw a perpendicular from O to the side HG, let's say this be OE, not OE, E is already there, let's say OT. So OT is drawn perpendicular to HG. Since OHG is an isosceles triangle, OT will bisect HG. So this will imply that now the idea is that why I am considering this isosceles triangle and drawing the perpendicular, I need to find the area of this regular nonagon. I need h, that is the length of the perpendicular drawn from the center to one side. I need the length of OT. So if I know the length of OT, that is in the formula, I will know h, and n I already know, n is 9, for nonagon n is 9, and a is already given, the length of each side is given. So I need to find h. So I am trying to find h, that is length of OT. Okay, so we will have OT perpendicular to HG will imply that HT will be equal to TG will be equal to half of HG, that is equal to A by 2. HT will be A by 2. Okay. Now in the right angled triangle, triangle OTH using Pythagoras theorem, we will have OH square will be equal to OT square plus HT square. Okay. So this implies that what is OH? OH is twice A. We have already found the length of the length of equal sides of the isosceles triangle of each of these isosceles triangle, as you can see in the figure, will be twice A. So twice A square is equal to what is OT? So OT, okay, so OT square, we are finding OT square plus what is HT? HT is A by 2. So A by 2 square. So this implies 4A square is equal to OT square plus A square by 4. So this implies OT square OT square is equal to 4a square minus a square by 4. This is 15, after simplification, 15a square by 4. So the length of the perpendicular from the center O to any side will be OT, that is 15, 15 that is the square of the perpendicular is 15a square by 4. So this implies OT which is equal to h, that is the length of the perpendicular from center to any side, will be equal to a square root of 15 a square by 4, which is equal to a by 2 multiplied by square root of 15. Okay, now we can find the area of regular nonagon that is A, B, C, D, E, F, G, H and I will be equal to, using the formula NaH by 2. What is N? N is 9, A is same, and what is H? H is A by 2 multiplied by root 15, this whole divided by 2. This is equal to after simplification, this becomes 9a square by 4 multiplied by 15. So this should be the area of the given regular nonagon, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 4. Problem number 4. ABCD is a square and EBCF is a rhombus on the same base BC. Okay, if the diagonals of EBCF, that is the rhombus, EBCF is the rhombus, if the diagonals of EBCF are in the ratio 3:4, then the ratio of area of ABCD and EBCF is, okay, let's draw the diagram first. Let's draw the square. Let's draw the square. This is the square, and we have the, so this is the square A, B, C and D. Okay, what will be the diagonal? Let's draw the rhombus. Okay, more or less this is the rhombus. My diagram will not be perfect. Okay, so E, B, C, F is the rhombus. They are having the same base. Okay, now no dimensions are given, only the ratio between the diagonals of the rhombus is given to be 3:4. That is, let's say we have the diagonals EC, diagonals EC, BF. Okay, it is asking to find the ratio of the area of ABCD and EBCF. Okay, let's consider the length of the square, each side of the square B, bx. So let AB is equal to x. So this will imply area of square ABCD will be equal to xs square Now, one side of the rhombus will also be x, because the rhombus and the square are both having lying on the same base BC. Okay. From the side length of a rhombus, we cannot find the area of the rhombus. We cannot find the only with the side length of a rhombus. We cannot find the area of the rhombus. We need the length of the diagonals. Please note that. I hope you know that area of a rhombus is equal to half multiplied by the product of diagonals. Product of its diagonals, that is diagonals. So the area of EBCF is the rhombus, will be half multiplied by EC multiplied by BF. Okay. Where we know that, let's say, the ratio of the diagonals of the rhombus are given to be 3:4. So let's say, as per the diagram, EC is to BF is equal to 3:4. 3:4. The area of the square, since we have considered the each side length of each side of the square is x, so area of the square is x square. Somehow we have to find the area of the rhombus in terms of x square. Then only we can find the ratio of the rhombus and square. Somehow we have to find the area of the rhombus in terms of x square, which means that somehow we have to find the diagonals. Somehow we have to find the diagonals of the rhombus in terms of x. Let me see. Okay. So we know that the diagonals of a rhombus bisect each other at right angles. Okay. Let's say the EC and BF are intersecting at the point, bisecting each other at the point O. Now, okay, in right angled triangle, triangled BOC, applying Pythagoras theorem, we will get that BC square is equal to BO square plus OC square. Now, since the diagonals of a rhombus bisect each other, we can say what is BO. BO will be half of BF. So this square plus, similarly, OC will be half of EC square. So this becomes BF square by 4 plus EC square by 4. Okay. Now, okay. Okay, so this implies what is BC? BC is x square. So we have x square is equal to BF square plus EC square by 4. This implies BF square plus EC square is equal to 4x square. We got this relation between x and the two diagonals. We also know the ratio of the two diagonals. From this given ratio, that is EC is to BF is 3:4, let EC, this is concept of ratio and proportion, let EC be equals to 3T and BF be equal to 4T. So this will imply BF is 4T square. and EC is 3t square is equal to 4x square. So this implies 16t square plus 9t square is equal to 4x square. This implies 25t square is equal to 4x square. This implies t square is equal to 4x square by 25. This implies t is equal to square root of 4x square by 25. This is 2x by 5. Okay, so t is 2x by 5. T is 2x by 5. Okay, so what is we can now find the diagonals in terms of x. So what is B? What is EC? EC is 3t. EC is 3t, that is 3 into t. T is 2x by 5, which is 6x by 5. And what is BF? BF is 4t. What is t? T is 2x by 5, which is 8x by 5. Okay, so now the area of the rhombus EBCF is equal to half into EC. The area of a rhombus is always half into the product of the diagonals. This is equal to half multiplied by what is EC, 6x by 5, and what is BF, 8x by 5. 8x by 5. This is equal to, after simplification, you will see this is 24 x square by 25. So this implies area, it has asked to find the ratio of area ABCD. So area ABCD divided by area EBCF will be equal to the area of the rectangle, the square is x square, divided by 24x square by 25. This, after simplification, x square will get cancelled out, is 25 by 24. So this implies that area, the ratio of the area of the square and the ratio of the area, the ratio of the area of the square and the rhombus is equal to 25 is to 24. Hence the correct choice is A. A is the correct choice. Okay, let's do the last problem. Question number 5. ABCD is a quadrilateral where AB perpendicular to AD and AB also perpendicular to BC. E is the midpoint of AB. E is the midpoint of AB. If the ratio of the area of ABCD and triangle DEF is 1:m, then the value of M is. Let's quickly draw the diagram. So this is more or less the quadrilateral. A, B, C, D. So AB is perpendicular to both AD and BC. Okay. So this clearly shows that AB is AB is perpendicular to AD and AB is perpendicular to BC, implies that AD is parallel to BC. So AD we get is parallel to BC. Okay. Now E is the midpoint of AB. E is the midpoint of AB. and it is forming the triangle uh, DEC, and it is asking the ratio of the area of ABCD. Now, since AB, okay, so ABCD now clearly becomes a trapezium where AD is the parallel sides are AD and BC, and the height will obviously be AB since it is perpendicular. It is the perpendicular distance between the parallel sides. Okay, so this implies that ABCD is a trapezium with AD, BC as parallel sides and height small h is equal to AB. Okay. Okay. So we can clearly, so we know what will be the area of the trapezium ABCD in terms of the parallel sides and the height, that is AB. Now it is asking the ratio of the trapezium and the triangle DEC. Triangle DEC. How do we find the area of triangle DEC? Now DEC probably we cannot find because we don't know DC, we don't know really ED, EC, and also it is not a right angle triangle. But what we can do is that AED and BEC are right angle triangle, Okay, let's now in this kind of problem where no dimensions are given, always never hesitate to assume the dimensions of some segments or any length or any sides of any triangle or any trapezium. If you think it will help you, always do the assumptions. Hopefully they will not matter, those values will not be required, they will get cancelled out. So my idea is that I know that I can find the area of the trapezium which will be in terms of AB, AD and BC. Okay, first of all, instead of writing AB, AD and AC repeatedly, let's say this length is X, this length is Y, and let's say the height that is AB is H. That is, let AB equals to X, BC is equal to Y, and AB is equal to H. Okay. Now we will have AE. Since E is the midpoint of AB, AE will be half of AB, which is H by 2. Sorry, similarly BE will be equal to AE will be equal to H by 2. So the area of the triangle, right angle triangle AED will be based on this H and the side X, and the area of the triangle BEC will be based on Y and the BE height. Okay, let's see. So I will subtract the area of these two triangles AED and EBC from the whole trapezium. That will give me the area of the triangle DEC. I don't know what will happen. Let's see. Okay, so first of all, the area of trapezium ABCD is equal to half the length of the parallel sides X plus Y multiplied by the altitude AB, that is H. Okay. Now what will be the area of triangle ADE? Using the formula half into base into height, base is AE and height is AD. Why? Because we know that AED, angle A, is right angled. This is equal to half what is AE. AE is h by 2, and what is AD? AD is x. So this is hx by 4. Hx by 4. Okay. What is area of triangle EBC? This is again half into base. Base is BC and altitude is EB. This is equal to half. What is BC? BC is y, and what is EC? What is EB? EB is h by 2. So this is YH by 4. Okay. This implies what will be the area of triangle DEC. Why in the problem it is saying the ratio of the area of ABCD and DEF? There is no F. I think in the problem it should be DEC. DEC. It should be DEC. Sorry, there is a problem in the. There is a mistake in the problem. It should be triangle DE, not triangle DEF, but triangle DEC. So area of triangle DEC will be equal to area of ABCD, that is the whole trapezium, minus the area of the two triangles, that is ADE minus area of triangle ADE. Sorry, ADE and EBC. EBC. This is equal to the area of the trapezium ABCD was h into x plus y divided by 2, and the area of triangle ADE is hx by 4, hx by 4, and the area of triangle EBC is YH by 4. Now, if I simplify this, okay, so this is h into x plus y by 2, and from the minus hx by 4 and minus yh by 4, if I take h by 4 minus h by 4 common, I have minus h by 4, I have x plus y, x plus y. Okay, so now if I take h into x plus y common from these two terms, I have multiplied by, I have half minus 1 by 4. Now half minus 1 by 4 is 1 by 4. So this becomes h into x plus y by 4. So the area of the triangle DEC is h into x plus y by 4, and also we see that the area of the whole trapezium was hx plus y, h multiplied by x plus y by 2. So clearly we will get a good ratio. So this implies area of ABCD divided by area of triangle, it should be DEC, not DEF, is equal to this is h into x plus y by 2, and this divided by area of triangle DEC is h into x plus y divided by 4. This after simplification will be 2. Okay. Now it is given the ratio is 1:1:m. So this is given as 1 by m. So this implies that 1 by m is equal to 2. This implies m is equal to 1 by 2. Hence the correct choice is D. D is the correct choice. Okay, this brings to an end in solving the 5 good problems of set 2 on the topic of area of polygons. Now there are unlimited number of problems that you can solve, which is not possible. So you have to solve, but you have to solve a good amount of by amount I mean good number of relatively hard problems so that your concepts are brushed up. So for each set I am solving 5 problems so that the video becomes so that the video is not too long, and so hopefully I will be able to make 10 sets of these kind of 5 good problems from each chapter, possibly more than 10 sets. Even 10 sets I think is not sufficient, maybe 20 sets. 200 to 300, let's say 200 problems solved from a chapter, good 200 problems solved from a chapter will give you a good practice, which means 40 sets. I don't know whether I will be able to make 40 sets or not, but I will keep on trying. I hope solving these problems will give you a good practice and evaluation of your understanding of the chapter concepts of area of polygons. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. The link of the PDF of this problem set will be given in the description below. In the other channel, in the other playlist, that is CBSE Maths 8 RS Agarwal, I will soon start the next chapter, which I guess is about what is the next chapter, I don't know. Let me quickly check. The next chapter is 3-dimensional figures, and also parallelly I will keep on solving 5 good problems from this chapter, that is area of polygons, in this playlist, that is Maths 8 Hot. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.